My co-author and I recognize AI as a very important technology, but one where there are a lot of flawed and overhyped claims. The book AI Snake Oil specifically is about recognizing that there is potential, but also warning readers about what they should take with a grain of salt. If we believed in superintelligence, the implications for everybody, especially business and policymakers, would be absolutely radical, right? Most of the ways in which we've structured our economy now would become obsolete. We came to the conclusion that superintelligence is a bit of a myth. AI is going to continue to improve in its capabilities very quickly, but there's going to be no point in time at which you have sudden economic impacts.
Welcome to ODSC's AIX Podcast, your gateway to the latest in AI and data science. This episode is sponsored by ODSC West, the premier AI Builders Conference celebrating its 10th year. Learn more at odsc.com and use the code podcast for an exclusive 10% discount. Sheamus McGovern, the founder of ODSC, will be your host today.
Hi everyone and welcome back. Today's guest is Arvind Narayanan, a professor of computer science at Princeton University and director for the Center of Information Technology Policy. And I'm very excited for today's conversation because Arvind is co-author of the widely read book, I'm sure you've heard of it, AI Snake Oil, which challenges overhyped claims about artificial intelligence and offers a clear framework for separating real impact from marketing spin. His earlier work helped pioneer modern conversations around algorithmic fairness and online privacy, and he was named one of Time's 100 most influential people in AI. In our conversation, he brings a rare blend of deep insight and critical thinking, calling for optimism grounded in accountability in both evaluating and deploying AI systems, especially agentic ones. Arvind, welcome to the podcast.
Thank you, Sheamus.
I'm so excited to do this podcast because a couple of months ago, a number of people I hugely respect recommended AI Snake Oil to me. And I got to say, that's been one of my best reads of the year so far. I was surprised by the depth of the arguments and how well they were presented, and really made me think a little bit more about where AI is right now and more importantly, where it's headed. But Arvind, can introduce yourself to our viewers, maybe tell them a little bit about yourself.
Sure. My name is Arvind Narayanan. I'm a computer scientist at Princeton University. I did my PhD in computer science, and the focus of my research for many years has been about bringing accountability to the tech industry. I think tech is ultimately a force for good. I consider myself a techno-optimist, but my vision of optimism is not about letting companies do whatever they want to do. I think an optimistic vision can only be realized if there are people who are thinking carefully about what could go wrong and how can we prevent those things from going wrong. And we've heard many times that tech moves too fast for regulation to keep up. And there's a lot of truth to that. But if so, we need technically informed people to act as a counterweight to some of the overhyped claims from the industry to push back on some of those. So that's been my role for many years. I did research on privacy. I built a team here at Princeton to reverse engineer the online tracking that happens on our website and apps. Today, that's well known, of course, but back when we started doing this, there wasn't a lot of evidence for it. So that helped in some small way to change some practices for the last 5 years. But for much of the last decade, my interest has been in AI. My co-author and I recognize it as a very important technology, but one where there are a lot of flawed and overhyped claims. The book AI Snake Oil specifically is about recognizing that there is potential, but also warning readers about what they should take with a grain of salt.
To me, it was quite interesting because it did open my eyes a little bit on this kind of rebranding of traditional techniques because what do you call it? Predictive analytics, or you call it machine learning or data science. I think you called it predictive AI.
Yeah.
And I think some systems are marketed as cutting edge AI, but they may actually employ relatively old statistical techniques like linear or logistic regression and merely rebranded as AI. So I think in your book, the point that came across very well that you argued that these AI innovations were actually older methods dressed up as groundbreaking technology. Can you discuss why this rebranding is problematic? And do you think that discrepancy is intentional or just people not understanding how these models work, or is it more nuanced?
That's a great question. And to be clear, we're not saying that large language models, for example, are a rebranding of old techniques. There is a lot of innovation going on, but at the same time, there's also AI that's used to predict who is going to commit a crime, for instance. And these types of technologies are not really similar to deep neural networks, generative AI, et cetera. And that's not because those companies are not innovative, but it's because when you're trying to predict the future, there's just not that much signal in the data, right? So we've looked at research, for instance, claiming that you can predict civil wars really accurately. And we've shown that you can't really do any better than using logistic regression, decades old technique, because the data sets are fairly simple and there's a lot of unknowns about the future. So the best you can do is to pick up these crude statistical patterns. And that's what these companies are doing for the most part. There's nothing necessarily wrong with that. There are two things we push back against. One is exploiting public confusion around what AI is and making it seem as if the rapid advances with generative AI are also applicable to these decision-making systems, who will commit a crime or who will do well at a job or in health insurance, et cetera. So that's really not the case, right? When your decision-making depends on predicting the future, you're really limited. Like maybe you can go from 50% accuracy, flip of a coin, to 70% accuracy. That's it. But that's the most you can go. It doesn't matter what kind of data sets and what kind of models you use. So that's one thing we push back on. And the second thing we push back on is, setting accuracy aside, how is it morally acceptable to make decisions about someone in the criminal justice system, not based on a determination of guilt, but based on a prediction of what they're going to do in the future? Today, when a defendant comes before a judge, their trial might be months or years away, and the judge needs to decide if they're going to spend that time in jail or whether they're going to be free to go. When these statistical algorithms are being used, here are some fundamental moral questions that haven't been adequately addressed.
Yeah, Arvind, that was one point in the book that gave me pause because I think you termed it as prediction versus intervention. So I actually went and looked up, for example, one case is I think it was cited in your book, and I think the state of New York did this where they raised the cost of bail, and it actually may have led to increased crime. So prediction versus intervention. Can you explain why accurate predictions don't always lead to effective interventions? And I think it's especially relevant, and that was a fascinating part of the book for me.
Yeah, that's exactly right. So I think the goal in these systems should be to intervene so that we reduce crime or look for better outcomes. These algorithms are also used in welfare, social services to see which children might be at risk of being abused by their families. So it's fundamentally an intervention problem. What is the best decision we can make? In order to apply machine learning, it needs to be first turned into a prediction problem. That's when you can bring in the machinery of machine learning. What that means is that you have to freeze your model of the system. You have to assume that the only interventions possible are predicting who is at high risk for whatever negative outcome, and then preventing them from taking that negative action, such as by putting them in jail. And that might not always be the case. Let me give one powerful example of this. There was a study where they looked at minor offenses in New York City, and it turned out that a lot of people weren't really showing up for their arraignment. If they don't show up, that leads to escalating negative consequences. One way you can approach this is in the machine learning way. Oh, we're going to look at everything about a person, where they live, what they've done in the past, their age, and we're going to predict, is this person going to show up or not? And if they're not going to show up, we're going to preemptively take some punitive action so that we can force them to show up or whatever. But another approach is to identify the causal reasons why they're not showing up. It turns out that in some cases they just forget. In other cases, the summons form is so confusing that people can't figure out what they're being asked to do. In other cases, their nanny doesn't show up and they can't leave their kids at home last minute. And so what this means is that we can actually help those people. Instead of predicting them to have bad behavior, we can try to avoid that bad behavior by sending them text reminders, by redesigning the form. When they did all these things, the fraction of people failing to show up dropped dramatically in that study. So that's one way in which good predictions not only don't necessarily lead to good decisions, but framing it as a prediction problem might close off some other avenues for improving the system.
Yeah, and I found the sections of your book where you highlighted different use cases very powerful because, again, being a practitioner myself, we focus on the training and testing of traditional data science, classical machine learning. But I think you made a very strong case. I was looking across all the various models I'd built over my career, and I realized a lot of them didn't involve these, what could I call it, these complex social outcomes you're talking about, right?
Hmm.
And trying to do predictions for something in finance, insurance, even the healthcare stuff I did wasn't necessarily in a high risk patient outcome
Yeah.
situation. So I did see, and it was an important lesson for me. You mentioned that predictive AI can't be used with every problem, especially problems where they have complex social outcomes because the models don't actually capture that. And I think you did a great job of connecting those predictive AI problems to fundamental limitations, right? In predicting those complex human behavior. If I was to be given that task of, okay, you need to model something in this environment, I'd be quite hesitant because now I'm more aware that predictive analytics or traditional machine learning or even generative AI could be an insurmountable problem and it can't be just done with data and AI alone.
That's exactly what we're hoping for. Start a conversation around the fact that data and analytics is not necessarily a solution to every problem. It can have a role. One simple way to reframe a lot of these things is instead of automated decision making, it's a way to analyze the data and provide insights to the human decision maker. The human decision maker can use their common sense, their domain knowledge to see if they believe that the correlation that has turned up in the analytics actually has a causal foundation, whether that's a basis for taking action or something spurious that they should ignore.
Yeah, because it's basically understanding what are inherently unsolvable problems with just AI. I wonder if it's possible to put a framework around that. What are some of the problems we shouldn't be trying to solve with just AI? I think those with high stake outcomes for people is definitely one. You gave us some great examples already, but anything else springs to mind where you see AI being used in places where it fundamentally shouldn't be? Just AI. You had some good critiques around AI and hiring. And I actually do believe that as well, because I see a lot of people gaming the AI hiring bots by using ghost text or white
Yeah,
text to putting
that's
all
right.
the buzzwords in the resume. So a human
That's
can't
right.
read it, but an AI would.
That's right. Yeah,
So it's almost like there's a war between these
exactly.
platforms. So if you can speak to that a bit.
Yeah, for sure. So in the book, what we say is that broken AI is often appealing to broken institutions. And I think
Interesting.
the hiring process is a good example. We get it why companies, HR departments in particular, are feeling the burden of getting hundreds, maybe 1,000 applications for each open position, and they need to automate this process. But exactly as you pointed out, what has happened is an escalation with AI use on both sides. I don't think that arms race is going to end well for anybody. That's what we mean by this is a broken process. It wasn't working very well to begin with. But to fix that brokenness, you have to put more humanity into it, not put more automation into it. Think about what are hiring processes where you can actually evaluate the applicant in more depth. Even simple things, at least in the software industry, that we're very used to doing, like doing summer internships with college students and using that to have a more in depth assessment of their abilities and fit for your company and then make them an offer. That's the sort of thing that we need to try to scale up, I think, ways in which you have actually higher contact between the company and the candidate before making the decision, as opposed to lower contact where you try to automate as much as possible. And to your point earlier about what are some criteria for where we shouldn't maybe be using this, let me give one more example. There are a lot of things that people try to automate where it turns out that the human performance of that thing is the whole point. And getting to the
Mm.
outcome is secondary. It's like the journey is the destination, if you will. One good example is from the recent election cycle. There was a candidate for mayor in Wyoming, in the town of Cheyenne, Wyoming, and he wanted ChatGPT to be the mayor. And he said if he were elected mayor, all decisions would be made by ChatGPT. And his view was that it's going to be so much more efficient and smarter than humans, and it avoids all of the messiness and fighting and politics. But I want to flip that exactly on its head. The reason that politics is so messy and so contentious is because that's the venue we've chosen as a society for resolving these deep differences that we have. To try to automate that is to miss the point of what democracy is. ChatGPT making decisions would not reflect the will of the people. And if you want governance to reflect the will of the people, whatever process is there is going to be very contested. I think that's another application that's exactly backwards.
Yeah, that's an excellent example. I'll have to look up that. A very interesting story. I guess anyone can run for office now if you think ChatGPT or Gemini or Anthropic is going to do your job. Speaking of jobs, another part of the book I found very interesting, and I was glad to see it. The whole debate around wholesale job replacement is scary for a lot of people. And I think your book did a really good job of cautioning against that assumption of wholesale job replacement, because you got to consider what drives me crazy about all these arguments is consider the nuance of automation's impact on labor, right? What should companies, and I guess more importantly, policymakers approach this responsibly? And given that nuanced impact on the labor markets.
For sure. I don't want to minimize the concerns. We don't think there's going to be mass job replacement, and I'll get to that in a second. But even if 5 or 10% of jobs are at risk within a short time frame of a few years, that can be very painful for a lot of people. It can lead to social destabilization, et cetera. So I do want to acknowledge that right off the bat. At the same time, what we're pushing back against is this idea that there are going to be AI agents in 1 or 2 years that are going to be drop-in replacements for remote workers and automate 20% or 50% of the jobs in the economy. We don't think that's going to be the case, and there are a few reasons for that. One is jaggedness. Jaggedness is the idea that AI capabilities in some areas are vastly superhuman, but in other areas, it can't even do things that a toddler can do. What jaggedness means is that the point in time at which AI is able to passively automate any particular task is going to vary a lot from task to task. And what we've seen historically is that as certain tasks in a job get automated, there might be 20 or 50 tasks involved in your job or mine or anyone else's job. As some of these get automated, the nature of the job changes, the job description changes so that people are focusing on the things that can't be automated yet. So I think that's one reason. Another reason is that Melanie Mitchell put it very nicely. This whole idea of even breaking down jobs into tasks, that's already very reductive. A lot of the hardest things are in the boundary between those tasks where you're using common sense, various kinds of task knowledge that exists in organizations to even figure out how to break up a bigger goal into many smaller tasks. And even if a lot of those tasks get automated, we think there's going to be a necessity for humans for the foreseeable future to be able to have a position of oversight of various AI agents that are doing various things. This situation where a lot of the specific cognitive tasks are able to be automated, but you need humans to put it together in the higher level function of the job, will that lead to job loss? Will that actually lead to more demand for jobs? That is hard to predict in advance. Historically, we've seen both of those things. When automation happens, similar to Jevons paradox, the cost of doing something decreases. So now there's more demand for that thing because you can more cheaply produce it. Sometimes that actually increases the number of people employed in a job. It's hard to predict that in advance. And so that comes to the question of what policymakers should do. Some of the advice people are giving to policymakers is based on predictions of what's going to happen. I think that's going to be very hard. So we think policymakers should focus on an approach of resilience where you make preparations to put yourself in a position to have a soft landing, regardless of what ends up being the impact of AI on the labor market as a whole or in specific professions.
Yeah, I think those are fascinating points, Arvind, especially if you consider the context of the debate around artificial general intelligence or superintelligence right now, because sometimes when I step into the AI bubble, listening to all the influencers and other folks in there, I'm convinced that artificial general intelligence is 2 years away. And then when I started working and researching AI agents myself, I realized, no, there's no way AGI is 2 years away. I love that term, jagged, by the way. But another part of your book, which I found quite to the point, is these future threats and AI alignment. And I don't want to underestimate that threat, but I've always been more concerned, as I believe you laid out in your book, that we shouldn't be so much worried about AGI right now. We should be more worried about what people will do with AI right now than anything that AI might do in its own because it's autonomous. So yeah, would love to talk about the human misuse of AI. Do you think the human misuse of AI outweighs the threat of autonomous AI itself?
Yeah, so maybe it outweighs it, maybe it doesn't. But here's the way we think about it, right? Even if you believe that one day AI capabilities will have advanced so much that it will have power-seeking behavior, as some people call it, where the idea is that in order to accomplish whatever goal we've set for it, it decides that the best way to do that is to take over all the resources in the world, and it can do that because it's superhumanly intelligent or whatever. Those are some of the concerns. I don't want to necessarily say that those concerns are wrong. I think they're certainly very premature. Even if that is a concern, far before AI gets to that point, it will get to the point where people can use AI to accomplish various kinds of bad outcomes. Whatever defenses we put in place against that threat, we're going to be able to evolve over time to deal with the threat of AI acting autonomously as well. We think that if we design things correctly, we can avoid that latter threat of AI acting autonomously altogether. I'll address your question of to what extent should we worry about AI misuse. I think this is definitely something we should be concerned about. I think there are two types of things. One is acute threats, where AI is used to make bioweapons, find cybersecurity vulnerabilities. Another extreme is a more diffuse threat, where it's not some nation state, where it's not some super malicious actor, but it's everyday people using AI in small, harmful ways. One example of that is the use of AI to create non-consensual deepfake nudes, for instance. And this is a problem that's affecting hundreds of thousands of people, primarily women around the world. I think both are things we should be thinking about, but the latter, it's the more diffuse kind of threat that is very clearly already here.
Yeah, and also you had a chapter in your book devoted to misinformation. If you can talk about misinformation as well and expectations of solutions there.
Misinformation is a perfect illustration of these two kinds of threat. One kind of threat is, oh, there's going to be a nation state that is going to launch a kind of deception propaganda project to deploy bots to confuse people, mislead them, and interfere in the results of elections. The other kind of threat is people posting so much AI generated stuff online that it's no longer seen as trustworthy. Our information environment degrades even further, and we don't have good ways for people who are even looking for reliable information to know whether they're looking at something reliable or not. The worries about super powerful malicious actors using AI to mislead people, we've looked at the evidence behind those claims, and we think they're somewhat lacking. It's not just that those haven't happened so far. We think there are structural reasons why that is harder to pull off than it seems. One such reason being that generating false information has never been the hard part. Getting it in front of people and persuading them has been the hard part. And AI is not helping with the distribution problem. That's more of a social media issue. What kinds of posts are being amplified by recommendation algorithms? That's a slightly different question. But degrading the quality of online discourse, that seems to be clearly already happening. Just as an individual, I can't really look at comments on social media anymore, and it's not worth my time to engage in discourse with people because 90% of the time it's not even a person anymore. So that kind of degradation has already happened.
Yeah, I think those are very valid points. And your prior work on this as well was also very insightful. So maybe I'll include some of those in our show notes. What's your own take on AGI? Do you feel like we're a couple of years away? Are you paying attention to that debate at all?
Yeah, so we just put out an essay called AGI is Not a Milestone. I encourage folks to look at it. More than happy to get into this debate. So we think that the whole concept of AGI basically is a myth, simplifying a little bit, but only a little. And what we mean by this is not that highly general and capable AI systems are impossible. They might very well be possible. But the idea that there is some sharp thresholds that we designate as AGI, that if capability advances to this level, it's going to have big impacts in terms of economic impacts or geopolitical impacts in terms of the arms race between the US, China, and other countries, or in terms of recursive self improvement, or anything else that you think might happen at this threshold of capability called AGI. We argue in significant detail that none of those things will happen. AI will have transformative impacts over long periods, but that period is going to be decades and it is going to happen gradually. There is no discontinuity that's going to happen in terms of AI impacts. We should think more carefully about where AI is right now in terms of capability, what the gap is between capability levels and actually useful products, and what the gaps are between those actually useful products and economic impacts. Our hope is to refocus the conversation a little bit.
Yeah, I actually haven't read this yet, Arvind. I'm going to include this in the show notes. Your post on AGI is not a milestone, but I did read your other post a few days ago, which I think you published last week, AI as a normal technology, which was a fascinating read. And you had a section there because I've been advocating this to a number of folks in conversations around, I think you call it the slow adoption of AI. AI is advancing rapidly. It's advancing at a pace faster than most people and definitely organizations can absorb it, right? It's kind of what one would call the slow diffusion of AI. So even as the AI capabilities rapidly improve, but for integration for critical tasks is slow for some very valid reasons. So maybe if you can talk a little bit about that slow adoption, and I
Yeah.
think AGI is not a milestone, speaks to that a little bit.
Sure. So I think human adoption is slow for two or three main reasons. One is the amount of time it takes to learn these new technologies and figure out how to integrate them into your workflow. We think this idea of drop-in replacements for workers is a little bit of a fantasy. Integration is going to be a much harder process of looking at your current enterprise software stack and figuring out how you can address certain pain points in a way that is responsible, minimizes the impact of hallucinations and AI errors and so forth. Learning that takes time, and most people don't have that much time to devote to constant retraining and figuring out how to use AI as opposed to actually doing their jobs. And I know this from experience. So my job involves staying on top of AI and thinking a lot about how I can incorporate it into my own scientific research workflows. So that seems to take up something like 10% of my time, something on that order of magnitude, right? That's a ridiculous amount of time. I can do that because it actually helps my research on AI. But for most people, they might be able to devote 1% of their time to figuring out how to integrate AI into their business processes. There's an order of magnitude gap there. And that's reason number one. Reason number two is I think a lot of the AI capabilities that we talk about based on benchmarks are actually over optimistic. When people use these in real world contexts, it turns out the capability is there, but the reliability is not there, for instance, right? And you need it to work not just 80% of the time, but 99.9% of the time. And that turns out to be a big gap. Privacy, security, and safety turn out to be big gaps. The user interfaces maybe don't allow for efficient adoption. And so, in many cases, these domain experts in law or medicine are making rational decisions. They are aware of the capabilities. They're aware that ChatGPT can be very good at medical diagnosis, for instance, but they have rationally decided that for other reasons that are harder to measure, it's not quite at the point where it can improve their workflows. So that's the second reason. And the third reason is that even if both of these have been tackled, in many cases, you have to change laws, for instance, change the rules on accountability, who's accountable if something goes wrong. You have to change organizational practices in many ways. Some people have talked about how software might need to move from seat-based pricing, which is for each person in your organization who's using the software, to value-based pricing. If it is true that these AI agents are going to be able to 10x your productivity, then seat-based pricing doesn't make sense because it's doing the work of 10 people, but you're only charging for one seat. And so you have to figure out new business models. And so those are organizational transformations that are going to take a very long time. We've seen similar things with past disruptive technologies like electricity. Figuring out how organizations should adapt takes decades, and we predict the same thing is happening with AI as well.
Yeah, it'll be interesting to see how the productivity debate plays out, and more importantly, how productivity is measured, because it was famously noted that it took a long time to measure productivity of computer use when computers in the workplace started getting widely adapted in the 70s and 80s and so on. Your second point is very interesting. Could we call this the least dirty shirt problem? Because we know that AI has flaws, right? There's flaws in the AI and the modeling, but we also know for certain environments, there's even worse flaws in the human decision makers. There are some use cases for that. Do you think there's some domains where even flawed AI can still outperform human decision makers?
But here's the thing, right? We've had decades, hundreds of years to evolve these various industries, these institutions around the idea of flawed decision makers, flawed human decision makers. And knowing that they are flawed is exactly the reason why we don't put individuals in charge of important decisions with no accountability, right? We have multiple people looking at things. We have checks and balances. We have appeal processes, et cetera. And that's exactly what I mean by part of the innovation that needs to happen is what is the accountability for AI-based decision making? So it's not a matter of don't use AI. Sure, let's use AI, but let's figure out what those processes are going to be, whether human processes or partly automated processes, to fix things when stuff inevitably goes wrong. And that's the thing that I think is going to take time.
Yeah, it'll be interesting to see how that plays out. So, Arvind, I want to switch to your ODSC East keynote talk, which is on AI agents. I have some specific questions, but maybe you can tell us first, what are some of the main ideas you're hoping to present?
Yeah, so we have a team of graduate students, undergraduate students, and others here. And together we've been working on improving the evaluation of AI agents. Our first thing we put out was about a year ago. We put out this paper called AI Agents That Matter. We made a few points about how AI agents are being evaluated. One thing we said, it's well accepted now, but at the time it was new, that looking at accuracy alone is very misleading because just by cranking up the amount of inference scaling budget, you can make your agent look better than another agent. So it's not telling you whether it's actually because of scientific improvements or simply because you have a greater inference budget to spend. So that's one simple example of how we need to change our benchmarking practices. You have to move from these one-dimensional leaderboards to Pareto curves. Moving to Pareto curves is hard, not technically, it's very easy technically, but in terms of our human practices, because we're just very used to having a linear ranking of models for any particular benchmark. If there's no longer a linear ranking, if there's a two-dimensional curve and different agents are in different points of that curve, it's hard to know how to interpret that. That's the first point. The second point is that a lot of the benchmarks we're seeing had flaws wherein it was possible for agents to do really well by essentially hard coding things. In traditional machine learning, train test separation is really important. And you hope that there is no leakage, there's no contamination between your train and test set. We've seen that a lot with large language models as well. If they're training on all of the data from the internet, is there contamination? With agents, there is a much worse version of the problem, which is that the human developer has seen the samples in the test set. So having known that, they perhaps subconsciously, without realizing it, are programming in how to deal with edge cases in ways that reflect what's in the test set. And you're never going to realize this by reading the source code of the AI agent. And so this kind of destroys traditional ideas of train test separation that we had. And so for this reason, we think a lot of the progress in AI agent accuracy is very illusory. In some cases, we do have people explicitly programming in hard coding solutions to specific test set problems. And so I think we need better practices to measure all this. So anyway, that's the gist of the AI Agents That Matter paper. And since then, we've come a long way. We've built something called the Holistic Agent Leaderboard in collaboration with people at many other universities and companies. We have a collection of 15 different agent benchmarks, and we automatically test various frontier models on these benchmarks in ways that incorporate these best practices that we came up with in previous work. I'd love to tell people about how the Holistic Agent Leaderboard works and why that's a way of doing evaluation that's different from what has come before. So all of that is the first part of the talk.
Oh, that's excellent. I will include that leaderboard in our show notes and I'll get a link to that. I was thinking about that because I know there are a lot of benchmarks out there. There's pros and cons around using benchmarks that seem to be getting more critiques. I think leaderboards like the one you're mentioning are gaining traction.
Yeah, exactly. If I can make one quick point. So we're used to upstream and downstream evaluation. Upstream evaluation is where you run your model on a particular benchmark, and downstream evaluation would be done by a company on their internal test set. They would provide a whole bunch of metrics, not just accuracy, but various other things that you care about. I think upstream evaluation is mostly dead, honestly. I would say don't look at upstream evals. This decontextualized idea of how a model is doing on MMLU or whatever is not relevant to any particular user for any particular downstream use case. HAL tries to be something new, which we're calling midstream evaluation. It's not quite upstream, and it's not quite downstream either. This is not in the context of a specific application. However, it is looking at a suite of benchmarks for various particular tasks like SweetBench and TabBench and various individual benchmarks. It does give you a more holistic picture compared to those highly abstract upstream evaluations, such as question answering datasets.
Yeah, I think that's a very valid point because it's hard to keep track of all the different benchmarks and what they're doing. One question I have, having worked with agents over the last year or so, is they can get very complicated very quickly because we're used to evaluating around a task that has the right answers. I feel like some of the use cases we're applying AI agents for, it's not clear what the right answer is because a lot of these evaluations, they don't fully capture that dynamic, non-deterministic or unpredictable nature of a real world scenarios. But I haven't figured out how evaluations of AI agents can evolve to handle tasks where there aren't clear right or wrong answers. Is there any practical strategy you can recommend for real world complexity?
I suspect it's unsolved, but I think we can look at an analogy to large language models. We've been good at evaluating them on tasks with clear, correct answers, like question answering. But then there are also tasks involving writing where there are not clear, correct answers. It turned out that increasing the general purpose ability of these models so that they're doing better on these concrete benchmarks was also making them good at tasks like writing to a certain extent. And so it might be possible that a similar thing might happen with agents. I don't think it's happening yet, where we really focus on the tasks that we can evaluate in a concrete way. But it turns out the general abilities that they're learning for navigating those tasks are also making them better at the things that are harder to measure. That's just a hope. I'm not saying that will necessarily happen. And the other thing I'll say is that it's extremely useful to have things like uplift studies where you give 20 people access to the agent and 20 control people don't have access to the agent. They go about their workflows and you measure accuracy and time savings, et cetera. So those are ways to evaluate AI agents that are much more costly than automatically running it on a benchmark, but they do give you a much fuller picture that's not possible just by automatically running it on a benchmark. And you can go even further and you have qualitative analyses. And I forget the author, but they wrote up this blog post called Thoughts on a Month with Devin, Devin being the automated software engineering agent. I think a lot of listeners might have seen that. It was extremely influential. So it has nothing to do with traditional evaluation, but it is a very useful way of understanding where an agent is for a particular domain.
Devin is a very good segue. We've brought that up a number of times in the podcast, but I'll share a link to that because in your abstract, you did mention specifically, and you've already addressed this, the gap between the hopes around AI agents. And I think you used the term underwhelming, which I think is fairly accurate. They're underwhelming real world impacts so far. And you did mention that there are some key engineering challenges that still need to be solved to deploy AI agents more successfully. For example, booking a restaurant table with AI agents is a famous example, right? And everyone's talking about this example of building a restaurant booking system with an agentic workflow, but I still have not been able to get an agentic workflow to be performant and do that. But yeah, I think your keynote's going to address that. Would love to hear what is the key challenges.
Yeah, for sure. Yeah, I think there's still a way to go. Let me make 2 points. One, we know in traditional machine learning how important it is to get the loss function right. If you don't have your objective, you're going to optimize towards the wrong thing. I think an analogous situation is happening with agents right now. You have to think about each thing you care about, have a term for that, and you have to figure out a set of weights so that you can add up all of those terms in your loss function. It's similar with agents because there are many kinds of failures that can happen, and the costs of each of those failures can vary relative to each other by orders of magnitude. So if you simply count up the number of errors, and that's what your objective is, you're optimizing for something really silly. In the case of the restaurant booking system, one kind of failure might be it just gets confused and gives up, and the other is it might book it for the wrong time or the wrong restaurant, or it might even put in your credit card number and make a costly action that literally costs you dollars in a way that was erroneous. So these are 3 different things that have 3 different costs. I would say roughly 1 to 10 to 100 in terms of the ratio of costs. But in the way that we measure performance and optimize performance, each of those has a cost of 1. So we've never really thought about the loss function. We have to get the fundamental science of measuring and optimizing agents right. I think we're still in the early days. It'll take maybe a couple of years before these types of agents can start working reliably. The other thing very quickly is so far we've tried to build agents with a lot of scaffolding. With newer agents like OpenAI's O3, we're seeing that maybe using reinforcement learning so that the model itself can learn these behaviors instead of them being hard-coded to some degree in the scaffolding could be a way to go. So that's potentially promising, but again, very early days. Remains to be seen how well that'll work. O3 is very good for tasks like web search, where the cost of errors is low, but it's not necessarily something that you would use for a restaurant booking. So we just have to wait and see.
Yeah, it is interesting because I was very skeptical on agents for most of last year, but it wasn't until the reasoning models came out. Again, you mentioned O3, O1 before that, DeepSeek, Claude 3.7 Son is a hybrid reasoning model. And then I've actually been quite impressed by Gemini 2.5, and the Quen models have been pretty impressive. What I'm fascinated with is planning. Right. So this kind of chain of thought and tree of thought and all that stuff. I guess my question here is one of the flaws I see is that a critical aspect is effective planning and reasoning over a long period. It's one thing to fire up an agent, but really we're looking to have agents that plan and reason over long periods. That's proven to be very difficult. Even with the advent of these very powerful reasoning models, agents struggle with long-term reasoning. Anything in the future that will make that more realistic, I see that as one of the key issues blocking successful deployment of agents at the moment.
Yeah, for sure. That's definitely one of the main limitations right now. I think things have been getting better with improved memory and greater context length, so the agent can operate longer without running out of its context window. Those have made things incrementally better. But the traditional planning literature in AI, as I understand it, has been primarily symbolic, but these are fundamentally statistical systems. Is there a way to get the best of both worlds? I don't know. It's not something I'm directly doing research on, but as I understand it, it's very much an open research question.
Yeah, we'll have to see. And it's significant because before there was Microsoft Windows, there was a command line interface, right? Bill Gates, he's suggesting that agentic AI in particular will fundamentally change how we interact with computers and software. I believe that, right? When I'm sending a message on my phone, I use Siri with all its flaws and seems to be getting worse, but I use Siri. A keyboard is one of my least favorite ways to interact with my phone. And I just want to juxtaposition now because going back to the AGI question, it's the Turing test, right? If agentic AI is able to book a restaurant, book a flight, do things that almost seem like superintelligence or do it very well, do you see it as a step towards AGI or is it more very much hyped on the hype horizon?
A few thoughts here. So when you say step towards AGI, I don't know what that means. It's almost cliche to say there are too many definitions of AGI, but in our recent
Yeah.
essay on this that I mentioned earlier, the point we made is that there's a reason there are too many definitions of AGI. It's not as if we understand what it means and have trouble putting it down in a definition. There's just something much more fundamentally confused about that concept. I agree that there will be an increase in generality, and we've talked about in our book a ladder of generality going all the way back to special purpose hardware for each task to Turing machines. It's important to have some historical context here, right? That's how confused this concept has been. They called it universal computer because they thought some major threshold of generality had been achieved, that you can have the same hardware for any task. And then machine learning gave you a step up in generality. You don't even have to write new software for any task. You can just collect new data for each task. So generality has been increasing for many decades. And I do think that there will be another increase in generality, but I don't think anyone can what the destination is at what critical threshold, if any, it's going to have these massive economic impacts. So that's one way in which I will push back on the framing of the question. But the other thing I want to say is travel booking agents. I think that's the example that everyone gives, but honestly, to me, that's one of the least well-motivated use cases for agents. And here's the reason why. So for me, the reason why booking travel is so frustrating is that there are so many different options. One of them might be cheaper, but longer, might involve a layover, an airline that I don't like, land at a time that's inconvenient, etc. And so as I start searching through Expedia or Google Flights, I gradually start to learn what my own preferences and constraints are. It takes me like 15 minutes of going back and forth with the system in order to articulate my specification. And so the challenge of travel booking is fundamentally a preference elicitation or a specification problem. That's the hard part. It's not doing the booking. It's not clicking the buy button. But even if you have these agents, you have to talk to the agents back and forth so that the agent can understand what your preferences are and then act on those preferences. So I don't think that's going to be revolutionary. As we start to build these agents for particular domains, we're going to have a better understanding of whether this will really help people or is it more of a gimmick? I think travel agents maybe are more of a gimmick.
Yeah, I think it was earlier on in your book. I think maybe it was the first chapter. You cautioned against the term artificial intelligence. It's almost a misleading term because people apply the term artificial intelligence to everything. I think you said there's a generative AI and predictive AI. And I actually just fell into the same trap when it came to AGI. So you make that point very well. But I do want to speak to your essay, AI is a normal technology, because I would encourage our listeners to read that. I'll provide a link to your Substack there on AI as a normal technology. Because, I guess the key point, you're framing AI as a normal technology rather than something that's unique or revolutionary. Why do you think that perspective is important? Like, why do you want people to take that perspective? Because you also say in the same essay that superintelligence is a myth.
Yeah, if we believed in superintelligence, the implications for everybody, especially businesses, policymakers, would be absolutely radical, right? Most of the ways in which we've structured our economy now would become obsolete. So everybody really should be thinking about how should we prepare for this post AGI or post superintelligence future? And that's what the AI companies are telling us to do. And no one knows how to do that. So we really started thinking about this. Are people just ignorant? They don't see what's about to hit them? Or do they actually have a nuanced understanding of the strength, but also the limitations of AI in their particular domains? And after thinking about this for 2 years, this has been the primary thing we've been thinking about ever since we turned in the first draft of the AI snake oil books 2 years ago. We came to the conclusion that superintelligence is a bit of a myth. AI is going to continue to improve in its capabilities very quickly, but there's going to be no point in time at which you have sudden economic impacts, because the bottleneck is not the capability. The bottleneck is two things: going from capability to useful products, where you have to solve various engineering challenges, which have been underestimated over and over by the AI industry, and the user adaptation and diffusion and changes in organizational structure. There is no way that these things are going to happen overnight. The final thought is the reason that superintelligence is a myth, to put it simply, is that it's never human versus AI. What human intelligence means has intrinsically relied on technology for a very long time. So it's going to be human plus AI versus AI. When we look at it that way, the case that these agents are going to be so much smarter than us that we'll have no choice but to hand over the keys to them and let them do whatever they want, we try to really come out strongly swinging against that argument. So you put these two things together, the picture that emerges is that the path of AI impact on the world, on the economy, on society, on geopolitics is going to be pretty much like any other technology. Things like electricity and the Industrial Revolution, which were very profound, but happen over very long timescales. And the danger that arises is not some kind of sudden collapse, in the AI case, existential threat from superintelligence, but rather the danger is weakening of our social resilience and democratic institutions, which are challenges that we have faced with previous general purpose technologies. So those are the risks we should be thinking more about.
Yeah, that was a word that popped out of me when I read that essay, the word resilience. And I think resilience versus restriction, not so much being so focused about restricting AI, but rather, I believe it was advocating for understanding the changes in AI and strengthening better AI literacy, ensuring that control is not in the hands of a few big tech players. Transparency is key. And of course, ODSC, we're very much advocates of open source, even though we know there's issues with that. But as I think you were saying, rather than focusing solely on restricting AI access, it should be more about building that resilience in society, which I think was an excellent point.
Thank you. Just as an example of AI and resilience, the reason we talk so much about AI and misinformation is not because of dramatically increasing technical capabilities, but rather when we look at historically what has been the defense against misinformation, that defense has been a free press. That's what enabled people to keep their head above the noise, because misinformation, horrible types of misinformation, have always been with us. Many people have documented this historically. The idea that we're in an unprecedented era of misinformation doesn't really hold up to scrutiny. So for us, what's really changed is not AI capabilities, but the decline of the free press to be a trusted source for reliable information. Our hope is that while people are panicking about AI, that becomes an opportunity to recognize that some of these sources of resilience in our society are collapsing, both in terms of trust and business models. Maybe we can use this as an opportunity to shed light on those problems and restore those institutions, or think about alternatives to those institutions.
Yeah, I think very well said, Arvind. Just my last question, which is going back to our earlier conversation. Were you surprised by the impact and popularity of the AI snake oil book when it was published?
Yes, we were very much surprised. I think just 6 years ago, I was surprised by the reaction to the slides called How to Recognize AI Snake Oil that I put up. Once again, we were surprised by the book as well. To me, what that goes to show is the nature of the AI discourse that we're seeing, where there's an overwhelming amount of hype. That's not inevitable. I think there's a lot of demand from people for deeper analysis. And so there's a lot of incentive in the market, if you will, for people to supply that kind of deep analysis. I encourage more people, especially those with technical skills, to understand what is going on in AI, to take up the role of engaging with the broader public to improve the quality of the discourse.
Yeah, and for those of our listeners who have not read the book, I would highly recommend this. I couldn't recommend it more, first and foremost. And then to follow your work, I've got a bunch of things I'm going to add to the show notes. AIsnakeoil.com is one of the key links. Anywhere else people should follow your work, Arvind?
Thank you. That's very much the best resource.
Arvind, very much looking forward to seeing you at ODSC East and hearing your keynote. Thank you so much.
Thank you, Sheamus. This is really fun. I appreciate how
Pleasure.
deeply you engaged with the work. Take care.
Thank you.
Bye.
Bye for now, Arvind. Thank you so much, and we'll see you at ODSC East.
Your engagement directly contributes to the growth and success of our community. Please subscribe now and don't miss out on the next enlightening episode. Today's episode is sponsored by ODSC West, the leading AI and data science training conference. Learn more at odsc.com and don't forget to use the code PODCAST for an additional 10% off. Supporting our podcast by subscribing not only helps our small dedicated team at ODSC, but also unlocks exclusive benefits for you.